Hello and welcome to another tutorial. So this tutorial is the first part in a series of ones, and this is talking about a heavily revised version of goal-oriented action planning that I have been working on for quite a few months now, actually. There's been a lot of iteration on it. So I'm going to give a bit of context on the series first. So this is going to be spread across several videos because there is a lot involved that I'm setting up and building here. Systems for debugging, systems for state machines, general infrastructure stuff, as well as trying to create a really flexible architecture for the goals and actions, and also having test scenes that cover things from like first person to real-time strategy to sim style ones, so a lot of different test scenarios. So there is quite a bit of sort of setup there before we actually get to much happening with the AIs. So there is going to be a lot of stages like that. I will be releasing these videos, 1 week after each other. So if it's a case where that lower level stuff, you're not interested in seeing that and you want to wait for the stuff with the behaviors, that will be coming out in the next coming weeks. So it is something where if you do want to jump ahead, that'll be okay. In the descriptions for each of the videos, I'm going to be making sure that there will be 3 links in particular. The first will be a direct link to the state of the repository as it was at the start of that video. The second link will be the state of the repository at the end of that video, and the final link will be to the actual completed package. So all of the code will be available for all of the stages from the beginning. The videos we're going to talk through the sort of process there for it. So that's sort of the setup. Now, in terms of with this particular video, I'm going to talk a bit about the premise of sort of what I'm trying to set up here, why I'm setting it up the way I am. And then I'm going to dive into the specifics in terms of the improvements, the setup like of that I'm going to do. So if you're just wanting to skip ahead when I'm starting coding, the time codes will be in the description below as well. So if you're more interested in just diving into straight the tech implementation, that is completely all good, got you covered. You can just do that directly from those time codes in the description below. But in terms of what the premise is, so previous versions of GOAP that I've implemented the monolithic version where you have one goal and one large action that achieves that goal. And it's always a one-to-one relationship there. You could have multiple actions that achieve the same goal though, but it's a goal is able to be fully completed via an individual action. The other version that I've also implemented was the microlithic version, where you chain together multiple actions and those actions manipulate state to achieve the goal. So there's things that I like and dislike about both approaches. And I've felt that there was a better way of doing it, and I felt that there was more of a happy middle ground. And so I've been doing a lot of iteration, experimentation for quite a few months now to develop a system that I feel hits kind of that sweet spot for me of being able to have things that are finer grained while also being able to have the planner be quite a simple process for it. Because that's one of the things that I don't like about the microlithic often is that the planning can be quite intensive, in particular can easily have a lot of memory churn. So that's not great, but the monolithic version, you end up with a lot of repetition, which is also not great. So I've tried to find that sweet spot in the middle. The key sort of stuff with this is I've taken inspiration from a lot of different areas. One of the areas is a GOAP system that I've worked with before, known as Tyrion, and that system it has the concept of resources. So for an action to run, it needs to use particular resources. So when an AI's, say, wandering around, that might use the leg resource and a torso resource, but it would leave the head resource free, which means you can have something run in parallel, like looking at points of interest. And that look at one runs in parallel. So with this setup, I wanted to bring in that resource capacity from Tyrion. I wanted to support that idea of having goals run in parallel. I also wanted to structure the code so that it was very cleanly partitioned and so that it was going to be easy to extend it in future, because this project is very specifically, it's an AI behaviors package, not a GOAP package, because I've set up so that all of the actions, you have base finite state machine action, and I've implemented the behaviors using that. But I want to also support things like a behavior tree based action and look at other ways of actually working with this. So this project is going to grow and sort of extend over time as I bring in things like the behavior tree side of things. There's also going to be a lot from this project that I then want to branch out into things like overhauling the Sims AI project, into the real-time strategy project, areas like of that. So that's why, if we take a look at what the starting point is for the project, which, remember, there will be a link to that in the description, there's a lot of different test scenes. I have test scenes for scenarios of a more sort of first-person environment, where we've got lots of things that can block line of sight. We've got a version of that that has various resources for interacting with. There is a more open world version of that where we have our terrain environment and we're interacting with that. And then finally, our Sims environment, where with this, we have various objects we can interact with. So we're actually going to be setting up behaviors that tie into each of these areas. Now, there is a bunch of common stuff that I've already put into this. And again, in terms of this code architecture side of things, I am making a point of using things like assembly definitions, using things like of namespaces. I have tried to, and part of the reason I built this fully from scratch, and then I'm going to rebuild it as part of these tutorials, is actually so that I can have a really clean architecture. And there are some parts of the architecture that I'm not super happy with, because there was sort of a balance I needed to strike of areas that I was refactoring. But I do plan to continue to iterate on this and improve on it and refactor it so that it is actually a really good sort of basis where if you want to have AI in your project, you can bring this in and then you can actually, pick and choose. Do I want, GOAP and I want to make use of finite state machines with that, or behavior trees with it? Do I want to just go direct to behavior trees? Do I want to go direct to finite state machines? You'll have that flexibility depending upon what your use case is and also what you prefer to work with. So let's take a look at sort of the initial things that we're going to be setting up. So I am going to be, if you see me looking off to the side at times, that is actually going to be me referring back to other code, because there is a lot of pieces that I've written for this. My current estimate is that there's going to be sort of several videos for this, and it's too much to keep in my head, and I spent a lot of time debugging it. So if I am looking off to the side, that is why. So one of the things that I'm going to be doing and what we're going to be looking at in this video is a lot of very low-level core infrastructure stuff. So a system for generalized debugging and a massive sort of set of improvements to the Blackboard manager and a system for being able to work with names in an easy way. And that might seem like a really strange, odd, specific thing, and like, why does that matter? So I think one of the best illustrations of this is if I look at the Blackboard Manager. The way that the Blackboard Manager is currently set up is it sort of is using an enum for the Blackboard key. I've taken the one from the Sims series here, and I've done various versions of this Blackboard that have different sort of setups to it. And I've never been super happy with it. Like this setup requiring modifying the enum all the time is not great. And I'd really kind of like this just to be something where it has a name. And also for generally looking up things, having a unique name that you can refer to can be really handy. And this is also something where you want to have a unique name, but you don't want to just be doing a lot of string comparisons because a lot of string comparisons get slow. You also want to make sure something is potentially globally unique. There's a lot of different factors there that you need to incorporate for it. So this is actually something that Unreal has solved quite nicely. And what I'm going to be setting up is a version in C# of their equivalent, their FName system. So the idea behind the FNames is you have something where for comparing two FNames, it's essentially an integer comparison. But at any point, you can actually turn those into a string. And the same string will always map to the same index. So it's a really powerful system, and it allows you to do some very cool things. So I'm actually going to set that up first. That's going to be my starting point, is I'll set up the FNames, then I will set up the Blackboard, and then the debugging side of things. So I'm going to have a NameManager. Now the NameManager is going to be making use of the new singleton class that I've set up. So we've got our NameManager, and let's open this up. Now this, when we set this up, there's going to be a bunch of things that we go and do with this. So, okay. Firstly, I want to actually set up the class for the FastName. So this is going to be the base thing that we will use. So I'm going to make this a sealed class. I don't want anything inheriting from this at any point. Now there's a couple of criteria this, or interfaces I want this to implement. So one thing is I need it to be equatable, because comparisons are going to be a thing that we will be doing. So we're going to have equatable and comparable. That. And it's good. So this is intentionally not based on mono behavior. That's not a coincidence or an accident. So, okay, what is the core thing this is going to need to store? Well, that's going to be a 32-bit uint, and we're going to have name ID. And what we're going to then do is, so that ID is when we're doing comparisons, that's what we'll actually check. Okay, so good starting point. Let's look at starting to set up the constructors for this. So firstly, I want to have a private one that takes no parameters, and that is going to set the name ID to 0. So we're going to use 0 as our invalid ID. So what we'll actually also have here is we'll create it up here, public static first name none is new. So this avoids anything else being able to create one without actually providing the additional information that we want it to provide. So what I want to have information-wise is I want to be able to say public FastName, and then you have to provide a string. Now, one thing you'll notice with the naming convention I use for any of this code that I'm writing is I have, because muscle memory is a thing, and I am so used to writing following generally the Unreal C++ convention, I've just ended up adopting that for C# because it's just easier to only try and keep one convention in my head, because what I was finding was when I was writing C# code, I would end up going and having to make corrections to it all the time because the muscle memory is just there from so much over the last year of writing C# or C++ code for Unreal. So how this will work is we need to get a name ID. Now this is where our NameManager down here will actually come in. It's going to be a singleton using our NameManager class. We get rid of our start and update. So the FastName itself isn't going to try and ensure uniqueness. It's going to be the NameManager singleton that ensures uniqueness. So I'm going to implement the interfaces here and then implement the actual logic in the NameManager. So what I want to be able to do with this is go, okay, well, NameManager, and I want to be able to say create or retrieve ID. And it's important that it's a create or retrieve because this name might already exist. So as long as the actual string is exactly the same, it will always coalesce to the same ID. That's the important thing. So, okay, that works. Then the other interface, well, I need to be able to get a string back, because that's also really important. So I can check if this is equal to none, then I'm going to return none. Let's go for that. Just to make it clear that it's not a valid string. Otherwise, it's going to be NameManager, and it'll be retrieve name from ID, and we provided the ID. So that's good. Now, there's a bunch of interfaces we need to support for things like equatable, comparable, stuff like that. These are ones that I do want to make sure that I'm actually supporting. But what I'm going to do first is I'm going to create these particular interfaces, just so it's not yelling at me. So we get rid of those errors. So then, okay, there's a couple of key interfaces we need to set up. Now, if I tell this to actually implement the stuff, we can see what ones it will sort of add in. We can do the same with iComparable, that it will give us the compare to. The other way that we can go about doing this in Visual Studio is when we actually have hovered over the class, we can tell it that we want to generate these equals and hash code ones. So we can tell it to generate the operators, and we can see it's created generally a lot of the stuff that we actually already need. And we can then just do the iComparable. Doesn't do that one by default, but that's okay. So now we've got a bunch of things to check and update. Now the equals one. So if we take a look at that, then what we're checking is that the other is not null. We're checking that the ID matches. This is just casting it to a fast name. So if whatever we have passed in is not a fast name, it will come and run this, but it will not be null. But it will be null if it's not a fast name. So that works. Getting the hash code, we can kind of get rid of that. That's a little bit of overkill because we can just go name ID, get hash code. There's no real need to go and do the sort of extra work there for that. The comparison side of things, that also completely works because the equals, those are just checking IDs. So those operators work. So it's really just the compare to. Now this, compare to in terms of sort of ordering things, we've got two ways we could go about comparing these and ordering them. One is that we could get the strings and we could order, based upon that. That's not really what I actually want to do. What I want to do is I want to have the comparison happen via the ID, because if we're wanting to sort them alphabetically, we need to convert them to strings. That's going to be a lot slower. So what I will do instead is this will return name ID compare to, and the other one. That's all I actually need to do for it. So that's pretty good. The other thing that could be handy is we could create something to easily test if an ID is none. So an option for that would be an implicit bool operator. So I'll actually put that down where we've got our other static ones here. So if we do public static implicit operator bool and fast name. Now I'm going to let it autocomplete that. I will actually do a renaming on these just again for that consistency. But in terms of what this would do is this would return if, and so the idea is this allows us to use a fast name just directly in an if. We don't explicitly check if it's none. That will do it internally. So what we could do is say, okay, well, if left is not equal to none, then it should evaluate as true. So now I'm just going to very quickly rename these ones just so that everything is following a consistent standard. Good. Now, what I will then set up is, after I've got these cleaned up, I'll set up the system for the actual singleton itself. So that's good. So, okay, let's look at the singleton itself. Now, this needs to keep track of a whole bunch of things. One of the big things that this needs to keep track of is it needs to hold this registry of this identifier maps to this string. So I'm going to have a dictionary that is going to map from a system uint32. Actually, did I already bring in system? I did already bring in system. So I could actually get rid of that from those. So it's going to map from a uint32 to a string, and this is our name IDs. So we've got that. We will also have uint32 of our next name ID, which we very specifically want to start that at 1. We don't want to be starting that at 0, because 0 is what we're using as our invalid one. Okay, so these are our sort of core interfaces that we need to get up and running. Okay, so let's get these up and running. So first thing I want to handle is, okay, well, the instance could be null. That is a possibility. If it is, I return 0. Otherwise, I need to go and I'm going to have instance dot create or retrieve ID internal in name. Now I have to give it the function a different name. That's a requirement. There's no way sort of really around that, unfortunately. So, okay, that's good. That's the sort of publicly accessible interface. Then I will have a internal uint32, and that will do the actual logic. So we'll get to that in a moment. Retrieve name from ID is going to be a similar sort of setup. So if our instance is null, then I'm going to return, similar to what I did here for none, this will be no NameManager. So it's very clear that something's gone wrong. I could also throw an exception, but I kind of wanted to return that as well. And then this is going to do a similar thing to what we did with the other one. Same sort of syntax like that. And again, I have an internal string, internal. And so that's good. Now we can look at getting these actually implemented and working. So for creating, or actually that should be instance dot. So for creating or retrieving one. Now, important thing with this is we want to try and make sure that this is as hard to break as possible. So what I'm going to do up here is I'm going to have a static object, and this is going to be the name ID's lock. And that is explicitly a new object. So then what I will do down here, where I'm creating or retrieving one, is I'm going to lock on that. And then what I will do is first check to see if there is actually that name. So does this name already exist? So what I can do is, well, I've got our name IDs. Now the name IDs is mapping from this particular key to a string. So our usual sort of methods for, we can try and get a value. So that will attempt to retrieve a value for a particular key. But that's not what we're after. We're trying to find the key for a particular value. We don't really have an interface for that. So the easiest option, and this is something where these names are not created frequently, so this process can be a bit slower. So what I'm going to do is loop through every key value pair in our name IDs, and kvp dot value equals that name. Then what I have here is our found name ID is 0. We will set it to the key and break. Now what that tells us then is if found name ID is equal to 0, we know we need to create it. And we can just return it at the end, because what we will do here then is, firstly, found name ID is our next name ID. We will increment that. Now I could do that on the one line, but I think it's better and clearer to do that on separate lines. And then what I will do is our name IDs, and we add that in. So name ID found, create. And that's it for ensuring that we have that unique ID. For doing the retrieval, that's actually pretty straightforward. We again want to, because we're dealing with something that we want to make sure we're safe with accessing it, we're going to lock based upon that. The found name is going to default to null. And what we will do is f name IDs. We try and get that value and output into that. Now, if we succeeded, then that's great. We return found name. Otherwise, we're going to return, and yeah, we might actually go for missing ID like that. So that's actually it to the name manager. That's all that's involved in it. Now, how we actually would then go about using it, I'll demonstrate with setting up a couple of sort of common keys here. So I'm going to create a C# script here that I'll just call common. And this is just going to hold a bunch of general information. So I could have a public static class of names. Won't be based on mono behavior. All this is doing is holding data. So I could have a public static, oops, let's make sure we get rid of that. We'll have a public static read-only FastName self, and we can just go, we don't actually need to even do that, we can just do self. Now what this means is from anywhere in the code, I could go common core.names.self, and it will always match to the same thing. I could inline create a new fast name and whatever I wanted to call it, as long as this text was the same, it will map to this exact same object. So it starts to make it easy to have systems that are actually disconnected. So you can have sensors feeding information into something while behaviors are pulling information out of it. And the ideal something in this case is that blackboard. So we're actually going to apply this over to the blackboard. First thing I'm going to do is I'm going to get rid of that actual sort of key there. I'm also going to bring it into our common core namespace because I want it to be properly grouped. So our blackboard, we did have it set up so that we could work with different types. And so I'm going to template this, or make it a generic, where we call this blackboard key type. And then that is going to get applied to all of these. So this just means that it's a little bit easier if we want to store other types of things. I'm also going to switch it over to the cleaner and neater structure for actually working with initializing these, because that's something that, with it being supported, it makes our code much neater. Now, while I'm here with this, I'm going to also add in a new type. I'm going to have a blackboard key type. I'm going to make it that it can also be caching mono behavior values, because that is actually going to be really handy. So, okay, so far so good. we roll this Blackboard key change through. So a lot of the things won't need to change too much. Most of the changes are actually pretty straightforward. Now we do have some of our generic ones here, like this. Those, it's just a bit of a renaming essentially that we're needing to be doing, which is fine. So that's good. Same for our things like the try get and try set. So most of these, anywhere where we had Blackboard key, we're just changing it over to this key type. Just means like I'm going to use FastName for it, but it makes it easy if I wanted to at a later point change that to something else. I'm going to make use of the auto refactoring stuff, because that actually makes my life a lot easier. So that's good. So we've added in those particular ones. That's changed. I do want to add in support for the mono behavior ones, because we haven't actually added in that yet. So we've got our standard sort of set of functions here, is our try get, well, our set, our get, and our try get. So I'm going to take this set of ones, because this is the ones all referring to game object values, and I'm going to change this to mono behavior values for each of these. That will be a mono behavior. So each of these change to that. Getting a mono behavior. So almost there with this. That's good. You've got those changed over. And I think I changed one too many. Easily done. Just fix that up. Turn that back to being a game object. So that's good. Now I want this to work for sort of anything where it is a mono behavior. That's actually a really important thing with these mono behavior ones. So what I'm actually going to do is I'm going to put this as set t, and then I'm going to say that that is t as well. And then I say where t is a mono behavior. So it just keeps it cleaner, neater, allows me to make it work with any mono behavior. The same thing is going to be true for this getting of the mono behavior. We template it like that, making it a generic, and we also, again, where t is a mono behavior. What that means for when we're returning this is we would say as t. Now it does change our try get here a little bit, because that, now again, we have the where t is a mono behavior. So these change to being t. Now the try get though, we need somewhere temporarily to store it. So what I'll have is a mono behavior, and this will be our temporary out value, and that's going to default to null. Then what I would do is bool result is equal to that. So our result, we're doing a try get, we will output it to temp out value. And then what I will do is I'll say out value. Value is equal to temp out value as t, and we return the result. So it just makes it possible for us to have this easily work with sort of different sort of setups there. Then, if we come down to our actual Blackboard manager, too much needs to change here. We will switch it over to using our new singleton system. What that means is I get to delete a bunch of stuff there, like those interfaces. The individual blackboards, those can stay the same, but we go to the cleaner structure for this. Blackboard, we have to say that the key type is a fast name. Like that. So that's good. Awake, we don't need to do anything, so we don't actually have an awake function anymore. All of these places where we were referring to a blackboard like this now gets the fast name added into it, just so that it's clear. Any of these ones where we were doing the new can actually go to the simpler structure again. So that's good. We've got our setup there where we can easily be, setting up these blackboards. They're now using the FastNames system. The only very quick thing that I would actually do is, again, because this is code that we have cleaned up, I'm going to go through and rename these particular ones. So through the magic of editing, I will jump ahead to where these are all renamed, but I'm going through essentially and renaming things to make it clear when something is an in value versus something being an out value, and also just generally following the Unreal style of naming of things. Just keeps it a little bit clearer. Okay, so after some editing and some renaming, this is all sorted. So we've now got a blackboard where the key has that rapid lookup performance of an enum, but it's able to be completely externally controlled, which means I don't need to be going and modifying this every single time I want to be adding in a key. The FastName system is also, while it doesn't currently support it, it would be quite easy to allow ones that are defined in the actual inspector, which means we open up to this blackboard becoming something that is fully, in inspector controllable. And that's really powerful because longer term with this sort of setup for the AI thing, I want to have it be more data driven. And have it that there is actually visual ways of working with these things. And so having this FastName system is a big step towards that, because the blackboards are kind of the unifying technology that ties all of it together, and the FastName is what allows that to easily bridge different sections of code that don't talk to each other, and also bridge into the actual inspector side of things. So, okay, so far we've got nothing that we can really see. That's kind of to be expected, because that's one of the things with this is the nature of it is there's a lot of stuff that we need to set up before we can actually get it running. So one of the things that I am going to set up next is a generalized debugger system. And we're going to just set up a fairly basic structure for this. So the idea behind this is I want to have something where, again, inspired from stuff that I've seen in Unreal, that we can easily and generically get debug information out of stuff. So what I'm going to create is a folder. This is going to be for our Game Debugger. So this is all sitting in that common core. So in terms of sort of setup for this, there's a few key sort of bits that I want to have. I want to have objects that are clearly able to be debuggable. So I'm going to create an interface, and this will be for a debuggable object. So you'll notice with this code, in all of the stages of this, I'm making a lot of uses of interfaces, and that is very intentional. The reason for that is to allow, most things are going to get the actual interface to stuff. They're not going to get the actual concrete version of a class, just so that can have, again, cleaner partitioning between areas. And so if you wanted to heavily redesign how an area works, there's already a predefined interface that you just need to mirror. So the actual debugger itself will be defined by an interface. So, okay, we've got things that can be debugged. We've got a sort of general interface there as well. I want to also support just sort of generalized, not something that is a high-level source of debug information, but that's something that might sit within that. So like an AI might own a Blackboard, and the Blackboard should be debuggable, but the Blackboard isn't a source of information on its own. So I'm going to also create an interface for something that is debuggable. So this is going to be our starting point in terms of our actual sort of interfaces. And what I'm going to start with, I'll just load up all of them. And I need to firstly change these over to being an interface, which means they don't inherit from mono behavior. We get rid of our start and update. We'll do the same thing with a debuggable object. And the same thing with this one. So interfaces, I'm using them a lot, as I mentioned. It's a way to really clearly and cleanly define how I want something to work. So, essential things that I want a debugger to have to implement. Well, it needs to be able to register a source. I don't want to have to be doing any finding of stuff. I want things to have to explicitly register. So that will be debuggable objects. I want to be able to unregister ones. So that's key essential sort of functions. Now, in terms of sort of the layout of this stuff, I want to be able to have it largely be displaying text. And again, I want it to be able to be fairly generic. So what I'm going to do is I want to be able to have stuff where I can add a section header. And that will have an associated bit of text. Then in terms of general text ones, well, I want to have just an add text, and that will just bring in text. I want to be able to support having that be indented or not. So I'm going to have a bool use current indent. Now that won't add in a new line. So I want to also have a version of that that is add text line. And we'll let that support the use current indent as well. I want to also have a add end line, because if I'm doing lots of add texts, I then might want to manually end the line. And then for indenting, well, I want to have push indent and pop indent. So just a general set of logic there. These are the sort of interfaces that will allow me to kind of structure, organize how things will actually work. So, okay, I think that's a good set of stuff for the debugger. There's later things that I could add for drawing, stuff like that. I haven't added that yet, but that is future things that I do want to actually add, is add in draw support for this as well. So, okay, what about our debuggable object? Well, one thing is I want to be able to get a display name for this. So I'm going to have a property debug display name, like that. I want to have a function that is going to actually gather the debug data. So this is going to be the main sort of interface. This is going to be one that doesn't actually get sort of overridden. So that's why it's sealed. So this is going to be gather debug data. It will be provided the game debugger and if the object is selected. Because we might want to, for some things, always output, and for other things, only output when it's particularly, when it happens to be selected. So it's in debugger. So, okay, what I would do is in debugger, this is where we can go and say, well, add text line. And okay, well, if the particular thing is selected, then I'm going to make it bold. Otherwise, we just leave it as normal. So that looks good so far. Now, with this, we do need to wrap that in parentheses so that it works. So display, add in the bold tag, we'll add in the debug display name. And then again, we repeat this for just doing the closing tag if it's needed. Like that. So, okay, that will add in the text line. So far, so good. Now, with this, I'm going to actually say, in terms of with the indenting, because we've got whether it should use the current indent, and in most cases, the answer is going to be yes, so I'm going to just provide true there. We could conceivably make that a default, so that's something where with the debugger here, would say true like that. And then when I go back over here, I can omit that. Because in most cases, we would want to use that current indent. There might be specific cases where we override it. So then, if it's selected, what I want to do is push the indent. I want to display the actual debug content. So I'm going to have a get debuggable object content that I provide the debugger, and if it's selected, and then I will pop the indent. So what I'll define down here, and this will be something then that child classes have to implement, is a get, and I'm just going to copy and paste it. And we have the exact same parameters. The difference is that because this one, I actually want to force things to implement. So, okay, a debuggable object is going to have to provide this property. It's going to also have to provide this interface, and we're automatically formatting and aligning stuff so that if it's selected or not selected, that controls what data comes out. And the big thing here, though, actually, is we probably don't want to do that, is we actually want to get rid of this, because otherwise it would only do this logic if it was actually selected. So that's better. So it does mean that we are, pushing the indent no matter what. But if we do output anything, even when it's not selected, that's probably ideal. So that's good. That's our debuggable object. What about this for our very basic ones? Well, this has that same thing of our debug display name. So that's an interface that it must support. And it then has our gather debug data and our game debugger and our if we're selected. So we don't need to do any extra controls for this. So the idea is that a debuggable object would be something like an AI, which is why it's always outputting stuff, it's putting in some highlighting and formatting, and it's doing indenting, whereas the individual sort of debuggable things within that would be stuff like a Blackboard, and I don't want to force indenting on those. I want to allow flexibility and control there with that. So, okay, we've got our three interfaces set up. What if we actually get our basic version of our debugger running? So, okay, I'm going to create a script here, and this will be our game debugger. Now, this is going to be an actual sort of concrete implementation of this. And I'm going to attach this to some associated UI. So let's get that UI built first. So we're going to give it its own sort of separate canvas. I will do sort of my usual setup where I scale with screen size 1920 by 1080. Then we're going to set up the actual panel for this. I'm going to switch over to the game view. And this will be our main actual UI panel. So game debugger panel. Now that I'm going to tint that. I'm going to also change the size of this. So I do want it to be anchored onto the left-hand side. Width-wise, probably something like 600 for now. And we'll offset it a bit from the top and bottom. Now this is something where I'm just getting basic versions in for that. And our game debugger is going to be attached onto that. So, our game debugger, well, first thing, it is going to be a singleton, like that. Get rid of those for now. But it is also going to implement this interface, which is immediately going to make it a grumpy. And that's fine, because we can just have it do bulk implementation of all of these bits. So let's sort out a couple of essential things. Well, okay, we need to be keeping track of our debuggable sources. So we're going to have a list of our debuggable objects. And that's going to be new. Now we also need to keep track of what source we're currently showing information for. So I'm going to have a current source index, which I'll default to -1. I'll give a little helper to actually grab the current source. So what that should do is if current source index is less than 0, then it's null. Otherwise, returns the index. So that's good. So what I can then do is, okay, other things I need to keep track of. Well, I need this text that it's going to be building. And this is where I'm going to bring in a string builder. And this will be our debug text builder. This will just make it easier to assemble the text in a bit more of a performant manner. I also want to keep track of our indent level. And while I'm not going to really be sort of messing with this too much, what I am going to have is a serialize field for a string, and this will be our indent string. And I'm just going to make it 2 spaces initially. I did test with using things like tabs. I found that was too much in the way of sort of indenting there, so I'm going to avoid doing that. So now we can start to get these various interfaces going. So let's go for the source registration, deregistration side of things first. So, okay, what I can have is for register source, that's going to go and say, well, if sources, does that contain that object? If it does, then I just return because there's nothing to do. Otherwise, what I do is I add that object, and then I would also go and say, okay, well, if current source is null, then current source index is equal to 0. So the idea being that if we have just gone and selected a source, or just added a source and we didn't have a particularly valid one, that one becomes valid. So the first one that gets added will be the valid one. Actually, I'll leave those braces in. So that's for registering a source. For unregistering a source, that one, not too complicated. What I would do is check if current source is equal to this one. Then I'm going to say current source index is -1. I'll remove the source. So sources, remove, and that object. So we've handled if we had the current one selected and we remove it. Then what I would also do is, okay, well, our current source, if that is null, then I also want to check, do we actually still have valid sources? Then what I can do is current source index is 0. So we're just sort of making it that it always defaults to a valid thing if it's present. Just means that you go and remove something and AI gets destroyed, it's still always going to be showing a correct valid thing. So, okay, let's start getting these other bits up and running. Well, indenting, it's pretty straightforward. When we push an indent, we plus the indent level. When we pop the indent, however, we don't want this to go negative because that would be less than ideal. So we're going to say indent level is the mathf max of 0 and indent level -1. So that's good. That's our indent handling. Our adding of a new line, that's actually pretty straightforward. We have our debug text builder and we just do append line. That's going to put in a new empty line there. Our add section header. So this I can do add text line. Now, the reason why I've got this as a separate thing is I want to actually apply formatting to this. So I'm going to set the color to orange. You could use other colors for this. I just find orange makes it stand out nice and clearly. So we'll have orange. Close off the color change like that. So that's good. We're adding in the text line. We're just reusing existing stuff. Now our add text. Well, if we have an actual indent that we're applying, so if we are using the current indent, then what I want to do is 4, and our indent is 0. We go up to our indent level, and then all I need to do is I want to go debug text builder, and I append the indent string. Then what I do here is I append our text. So that's good. Now add text line. It's not really much different. We can do add text like this. We use the current indent, and I can just then do an end line. So, okay, pretty straightforward for a lot of the logic of what we need. It's not really having to do too much. So, okay, so far so good. Now, obviously, I want UI associated with this. So I'm going to have a refresh UI function that we'll get to in a moment. But the key thing I want to do is then in start, I want to run refresh UI. In update, I also want to run refresh UI. We're actually going to be using it in a lot of places. So that's good. Now, down where we were adding in the particular sort of sources, things like of that. Here, well, we know we're going to need to refresh the UI in this case. So if it was null, we refresh it. We do the exact same thing here. The difference is that actually we kind of want to refresh it even if there are no sources. If this was the one that was actually removed, then we should refresh it no matter what. So what I would do is this logic here. So if sources count is greater than 0, then we'll update that. But we always refresh the UI. So even if there's nothing to show, we'll do a refresh so that it can actually figure out what it needs to. Now, in terms of what the refresh UI needs to do, it's actually not that much. There's not a lot to it. So if our current source is not null, which is likely to be the main case, if it's not null, then what we need to do is we need to firstly show the information for our selected object. So we build that text for the primary one. So what I'm going to do is loop through this. So in terms of what our refresh UI does, well, okay, our current source could be equal to null. Now, if that's the case, then we're going to largely early out. There'll be a couple of little things we do before here, because again, I'm wanting to decouple this from the specific bits of technology you might be using for displaying the UI. So, okay, that's, a good part to this. What I want to do then is we might have null sources. So I want to get rid of any of those. So remove any nulls. And this is the case for if we've forgotten to clean them up. This is the point to actually do that. So index is our sources, count -1. We just do our usual reverse logic. What I check is if that source is null, then I'm obviously going to be removing at that index. And if index is equal to our current one, so if it was the one we were already showing, then we're going to reset this to -1. So I'll actually do the removing of nulls ahead. Actually, no, I don't need to do it ahead of that because we would have already cleaned stuff. So I will actually then remove this and put it underneath because we could have gotten rid of the source at this particular point. So, okay, that's good. Got the cleanup logic there. So now we can build the debug text. So our primary source is current source. And then all I do is I loop through every source. And firstly, our debug text builder, I tell it to clear. Then what I'm going to do is I'll say our current source, and we gather debug data that provide ourselves, and whether we're selected or not is if source is equal to primary source. So that is going to gather all of the debug data. Now we need to actually do something with that text. And again, like I said, I want to have this decoupled. So what I'm going to do is I'm going to bring in UnityEngine.events, and I'm going to have two events here. One is going to be a string, and this will be populate UI selected object name. And the other one is going to be our debug text. Then what we do down here when we're refreshing the UI is, okay, well, debug text, we invoke it with the toString on our debug text builder. If the current source is null, then our debug text gets invoked just with an empty string. We could also invoke it with null. That would also work. Really depends upon how we want to structure the rest of the code. I'm going for just providing an empty string. But we also then have our selected object name. So we're going to invoke that. No sources. And then otherwise, we invoke it with, and we can put current source and our debug display name. So that gives us our sort of essential setup for this, which is really handy. So, okay, we've sorted through all of that. The one final thing we could do here is if our current source index, or if our current source is null, and we still actually have sources present, then we can set our current source index to 0. So we're just always displaying something if we can, which I think is useful. So, okay, we're ready to get that set up and working. So we've added our game debugger onto this. We can start to create this UI. So our UI panel here will have our header, our controls, that will be. Now I'm going to, for most of these, turn off them being a raycast target. That's important. So this one is going to be there, and then we'll have another panel that is going to be the debug text. Now our controls, I don't want that actually taking up all of the space, obviously. If I make that 50, maybe 75 is about right. And this one gets offset like that. And we'll tint both of these again and go and turn off being a raycast target. So actual debug text, this will be the debug text panel, roles panel. All this needs to be is debug text. I will make this so that it actually fits to the entire area with just a small margin. And we do want to mess with the sort of font size for that because we do want to be able to fit a fair bit of information there. So that's something that is important with that, of being able to have enough display data there that we can actually sort of fit everything in. So what I'm going to do is just paste in a rough, good old lorem ipsum, and what we can do is we can control sort of the font size there just to make it be something that's going to be a little bit more reasonable to fit in a fair amount. So that's better. So new lines, everything like that are working, so that's good. So, okay, so far so good. We can actually hook up one of these interfaces, because what this will do is that will actually connect to the debug text, and we already have a dynamic here for setting a text. So that's a handy sort of process for this. Now the controls, we're going to have 3 controls here. So we're going to have a button, and this is going to be previous. We'll have another one that this is going to be for the next. So button previous will be aligned to the left-hand side. That might make that 50 wide. And its text is just actually going to be a less than. And button next is going to be a greater than. And similarly, it will be aligned over here. We adjust our pivots again so that we can just get all of this nicely positioned with the 50 like 0. We're going to make the text a lot bigger so that that letter or the symbol fits sort of nice and cleanly. Could probably go larger. That's good. So we've got previous and next buttons set up. And then in the middle of that, we will add in a bit of text for this is current object name. good. So current object name, we will adjust the sizing. Again, similar to what we were doing with other ones. But I want that to be aligned in the center. And that text, I do want to make sure it's not a raycast target. I'll do the same for the debug text. Largely really only want these buttons to be valid raycast targets. And the object name, have that nicely centered. And I can link that up as well then for actually setting things. So we can link up current object name and the setting of text. We can link up our previous button because that is going to talk to our Game Debugger. Now we don't have the function for this yet, but we will in a moment. Then our button next also can link up to that, and then we'll set up our specific function for this. So far, so good. Now, what I want to actually do is set up a couple of helpers here. So public void. And so these are the ones that are going to handle the selecting of the next and previous. So I have UI on select previous and a public void UI on select next. Now what they need to do is not too much. If the sources count is 0, we just do nothing because there's nothing we can do. Otherwise, for going to the previous one, what we would do is say current source index is current source index -1 plus the count of them, and then we modulus it with count. That'll allow it to wrap around. And then we just do refresh UI. Then in our onSelect next, very similar. You can actually just duplicate that, paste that in there. Now the thing that changes here is that goes to just being +1. So far so good. We can then link up those functions because now we actually have the proper controls for it. So this is our button previous. And then we have our button next. So that's good. So with this setup, we could test this and we should see largely nothing. But what we'll find is when we run it, it's actually going to get super grumpy. And that's because what we want to do is we want to actually expand this test here and check not just that the current source index is less than 0 for returning null, but if it's less than 0 or if current source index is greater than or equal to the number of sources, then it's actually invalid. So we've got a couple of cases for where it's invalid. So now if we go and test this, then we can run that and we don't get any errors. It shows correctly that there are no sources. Now I can turn that into a prefab, which I'm going to do because this is something where we want this to be in all of the test scenes that we have. So I will go and add that into all of them. So we're in the Sims one, going to go to the first person one, and in each case I will just bring in that debugger prefab. So I have that in every single one, our RTS one. So this is going to make our lives a lot easier for when we actually get to testing and implementing the behaviors, because we've got everything sort of up there and running with this. and then the village test scene. We'll load that and bring in the game debugger. So that's good. We have those essential bits up and running. Now, there isn't a lot that we can see with this. That's kind of the nature of having stuff where we're setting up a lot of infrastructure. So there's been a lot of setting up of infrastructure, a lot of laying the groundwork for actually building the systems. And that means that it takes a while. And that means that there's sort of a lot less that we're doing towards getting visual results. And that's one of the challenging things when you're setting up full-on AI systems, essentially, is it takes a lot of time to get things all set up because getting them set up takes a lot of work because there's so many bits of groundwork we have to set up for this. So as I said, the whole series of videos is going to be coming out over the next several weeks. You can, if you're wanting to jump ahead, wait till one's come out. The code for all of the different stages is going to be there, so you can go in and do that. This has been obviously a fairly intense one, diving into a lot of basic stuff, but there's going to be a lot more cool things that we'll be setting up in future ones. So next time we're going to be starting to look at things like our state machine system and stuff like that and getting those things up and running. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, it really helps out, it's really appreciated. If you're looking for the code for the project, there are links to that in the description below. As I said, there is 3 links there. There is a link to the starting point, there is a link to this finishing point, and there will also be a link to the completed package there. So those are all there and available. The next part of this series will be out next week, depending upon when in the future you're watching this. It may already be out. And so those will be there if you're wanting to check those out. If you've got any questions, chuck those in a comment below. And if you're looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description below. But until next time,